Welcome to this lesson on designing an application and creating the user interface. After viewing this lesson, you will be able to recognize the steps taken by systems analysts and programmer analysts in identifying system requirements and incorporating these into the system design. Understand the benefits and limitations of flowcharts, IPO models, and toe charts. Plan an application using any or all of these tools as needed. Before any programming can be undertaken, an application's requirements must be determined and documented in detail. Systems analysts or programmer analysts will study the existing system, manual or automated, and document current features and functions. They'll gather samples of existing forms and reports used to obtain input data or produced as output. Finally, they'll interview users or stakeholders to further identify requirements for the new system or application. Here's an example of the systems analyst's interview notes for the Say Cheese Company, a company that sells cream cheese pies and needs a new system. Orders for cheesecakes are taken by phone. Cheesecakes are priced at $25 each and are available in two flavors, vanilla bean and strawberry. Salespeople record each order on a form containing the customer's name, address, and number of each flavor of cheesecake ordered. Salespeople then calculate the total number of cheesecakes ordered and total price of order, which already includes a 3% sales tax in the price. The sales manager feels that having salespeople manually perform necessary calculations is too time-consuming and error-prone. Here's an example of the Say Cheese order form that is used for the current manual system. The form records the customer name, the customer address, the customer city, the customer state, and the customer zip. It also records the quantity of vanilla bean flavor pies to be ordered, the number of strawberry pies ordered, and then the tally is made by the clerk to determine the total of the order and the total price. With the features of the existing system documented, and with interview notes in hand, as well as any reports or forms used by the current business processes, the systems analyst will then start to identify the application tasks. These include what information will the application need to output to screen, printer, file, etc. What information must be entered, the input. What processing calculations are required to transform the data entered into the desired information or outputs? What causes the program to end? And finally, will previous information need to be cleared from the screen before new information is entered? At this point, we're almost ready to produce the detailed design for the application we will begin to code. Regardless of the paradigm that we will use, the process is similar. Traditionally, in a procedural paradigm, we would undergo the steps of identifying the required outputs, corresponding essential inputs, and processing needed to transform the latter into the former. This is an IPO model, input, process, output. Once we've identified all the inputs, processes, and required outputs, we would develop a detailed flowchart of the logic to be implemented. Then we would design the input screens, prompts, and reports. For an object-oriented or event-driven paradigm, using a graphical user interface, we would do this slightly differently, but all the tasks are still present. We would identify the application tasks. We would map the tasks to the objects that will be responsible for taking care of those tasks. And then we would identify triggering events which cause each object to perform its assigned task. We'd finally design the user interface and reports. Let's first look at this through the lens of the classic IPO chart. Having analyzed our diagrams, our interview notes, and our preliminary analysis, we can identify that the cheese shop inputs will include the customer name, the street address, the city, state, zip, the number of vanilla bean pies ordered, and the number of strawberry pies ordered. We would also assign the variable types for these. So all of our customer name, city, state, street, zip code would be strings, and we would need integers for the pies. We won't be selling any fractional pies, so we'll use the integer data type. It's a little more compact and efficient than a floating point or decimal data type. And the one thing that may be surprising here is zip codes typically in the US are all numbers, so why would we use a string? Footnote here is that anytime you're dealing with something that looks like a number but will never be used for mathematical purposes, won't be adding, subtracting, or doing any calculations on it, it may look like a number, but it is in fact just a symbol representation or a string, like a text string. Having identified the inputs, we will next take a look at the processes needed to transform those inputs to the desired outputs. The processes here are 1, to calculate the total ordered, and 2, to calculate the total price. So the first gives us the total number of pies in the order, and the second, the total bill. The outputs we need to produce, some of these will repeat the inputs if we are reiterating things that we've input on the report, or the bill of sale in this case, and these include the customer name, street address, city, state, zip, the number of pies ordered, both vanilla and strawberry, the total pies ordered, and the total price. Again, we will note the data types for the variables representing these values. Notice that total price is decimal. Now, even though we're only ordering a whole number of pies, we can't order fractional pies, and right now, pies are a nice whole dollar price of $25 each. In the future, we might elect to change the price of the pie, and so in a forward-looking moment of clarity, we've made the total price a decimal value. So if we end up with partial fractional dollars in future, our code will not have to be modified in order to accommodate that. The first step in converting the IPO chart to a procedural program design is simple. We need to declare the variables, each of an appropriate data type, to store the inputs to be collected. This comes right out of our IPO chart. But the inputs are not the only things for which we will need variables for storing values. We will likely want to store values to be output. Many of our inputs will be recycled as outputs, so we do not need to duplicate those. But we will need to add variables for the results of our calculations. Sometimes we may declare additional variables for intermediate results from our calculations, but in this simple program, they are not necessary. Note that in our flowchart here, variables tote ordered and tote price have been added. In the Flowgridim tool that we're using, all non-integer, non-whole number numeric values are referred to as real. In the Visual Basic language, those would be decimal, double, or floating point values. With variables declared, we can now add code to get the inputs. We first output a prompt informing the user about what is expected. A prompt is simply an output statement to tell the user what we're looking for. Then we store or assign the user's input for that item to the corresponding variable. Having gathered all of the needed inputs, we can now process them to produce the results. In more complicated programs, we may need to gather some inputs, do some processing, and then gather additional inputs based on our intermediate results. In this simple example, we can gather everything up front. With all of the elements needed for our output stored in variables, including the results of our processing or calculations, we can now output the results. I've chosen to concatenate multiple outputs together using the concatenation operator, or ampersand sign. It would also be reasonable to output elements one at a time, using separate output statements. The Flowgridim functions toChar13 and toChar10 generate the carriage return and line feed codes, which start a new line. Now let's see our logic in action. Let's change this to a more reasonable view so we can discuss the flowchart and what is happening here. Okay, so to recap, our program begins and we do our declarations of each of the variables we'll be using in the program. And then we generate a series of prompts followed by inputs to store the variables, assign them to their respective variables, store the values to the respective variables, get those from the users. And after we've completed our inputs, we're ready to do a little processing, a little calculation. So here we use the inputs to determine the total number of pies ordered, and the total price is going to be $25 times that sum. And then we're ready to output things. Now, in many programs that are a little more complex, we might have to do a series of inputs and processing and then do some more inputs, gathering additional inputs that are determined by the results of intermediate processes. But in the case of this simple program, we can gather all of our inputs up front, process them, and we're ready to do our outputs. Okay. And so now we're ready to do our outputs, and it would be perfectly reasonable to do a series of output statements. I've taken a different design approach, and I've concatenated or joined all of the elements to be output together into a single statement. Makes for kind of a long statement, but you could see our flowchart was getting kind of long and tedious anyway, so this is maybe a better choice for me. And so there's our output, and then there is the exact characters known as a string literal, a whole bunch of equal signs, and the word order report and a bunch more equal sign. And then there's this funky function toChar. toChar takes a numeric value and turns it into a character code for characters that can't just be typed and understood because the editor would think that they were commands to the editor rather than content for the file being created. And toChar 13 and toChar 10 are the carriage return and line feed pair that generate a brand new line. Moves the cursor down one line and starts it over at the left-hand side of the screen. And so that's what those two things are doing. They're generating the new line. So we're going to have equal signs with an order report phrase in the middle of it, and more equal signs, and then new line, and then the string literal name followed by the value of the customer name, address, city, state, zip on the next line. And then a label, quantity strawberry, and then the value of the number of strawberries ordered. Same thing for vanilla, number of vanillas ordered, then another label, total ordered, and the sum of those two values, and then total price. And here the result stored in toPrice, which was $25 times the total quantity ordered, will give us the total bill. So let's run that and see how that operates. All right, so enter the customer name. My name is John, and the address, 123 Happy Place. And the customer city, Ventura, California, 93004. And let's have 3 of the vanilla and 2 of the strawberry, please. And there we go. So this has generated our output. There's our order report, all showing in between equal signs. John, address, Happy Place, Ventura, 2 and 3 make 5. 5 times 25 would be $125. So that all checks out. Next, let's see what would happen if we converted this flowchart, the design of our logic, into some actual procedural VB code in an old style VB console. So let's go ahead and in our tools, we'll go to the source code viewer, and I'm going to go open up our special template. And that's converted this to VB code, specially crafted for our CIS-119 course. And I'm going to copy the contents to the clipboard. Now let's come over to our Visual Studio, And let's create a new project. And this is going to be an old school console project, all text-based. So Visual Basic, it's going to be a console app in the .NET framework. Okay. And after a moment or two, our project should be set up as an empty project and ready for us to paste in our code. All right, so I'm going to replace everything in the module. And if I just press Control V to paste what's in the clipboard, this is our code that was generated for us. Ordinarily, old school, we would have taken our flowchart design and we would have transcribed it or transliterated it into the corresponding code statements in the language that we're using. But very conveniently, Flowgorithm has done that for us. And so let's test it and see if this builds and runs properly. Okay, so the program has compiled and it's prompting us to enter the customer name just as we expected. So JON and customer address 123 Happy Place. Customer city is Ventura, California 93004. And this time let's buy 4 of the vanilla and 6 of the strawberry. And here's our report. John at 123 Happy Place, Ventura, California. 6 and 4 makes 10. 10 at $25 a piece, $250. And so our code is working very happily. And we can just press enter to end that. At this point, I hope you're feeling pretty comfortable and confident that you get this whole IPO thing, the input process output model and flowcharts, and this is making a lot of sense to you. And you're probably thinking, well, can I just get on with the design? Well, not so fast. And here's the problem. Back when we were doing console-based, green screen programming and really controlling or maybe over-controlling what the user did in what order, this worked really well. However, here's where things start to fall apart when you bring in a graphical user interface. And graphical user interfaces, we can categorize the kind of program we're doing here several different ways, but one of the things that we're doing is event-driven programming. So instead of procedural programming, event-driven, and in this case, the user can choose to trigger different events in different orders than we might anticipate. And probably the easiest way to understand this is to see it in action and see the kind of hash it makes out of our nice orderly world of the IPO chart and the flow chart, and why this is going to complicate our design a little bit. We need some new tools. So here's the working Say Cheese order form application. Okay. And if we were to be a nice complacent user, we would do this exactly as the old school flowchart asked us to. We would enter our name. We would enter our address. We would enter our city and our state and our zip. We would enter correctly some integer quantity for vanilla bean and for strawberry, and then we would push the calculate button and the results would be displayed. And that would be all very nice and happy. And that's exactly our view of the world, very linear. It has to be done this one particular order. But this user interface gives us a lot more freedom than that. Let's clear it and start again. So maybe I don't put my name in first. What if I wanted to first put in my address and then put in my zip and then come back and fill out my state and the city. And maybe I'm not even finished putting my name in, but I'd really like to see what is it going to cost me if I want 5 vanilla bean and 5 strawberry. Let's calculate that, and then I'll come in and put my name on the order. Well, uh, the flowchart totally doesn't anticipate doing things in a free form, out of order kind of thing. Every time we talk to one of these controls, and these controls, we could start calling them objects. Once we choose to interact with different objects, those objects run their code independently of other objects, and we can interact with them independently, and yet we still get a whole cohesive result out of this thing. And so, how do we model that? How do we design that? And that is why we need something a little bit beyond the IPO model and more than simple flowcharts. Now, flowcharts are still very useful, particularly for beginning programmers that are learning to program. So we're going to continue to use them. But you can see that as soon as we get into a paradigm where we are object-oriented and we are event-driven, so the user can trigger different events, an enter or an entry made on the name text box or the address text box, and those can be done out of order, out of sequence. It's great that the user has a lot more freedom, but it really plays havoc with the programmer analyst trying to design this thing cohesively. How do we represent that? Now, to be fair, there are additional template symbols and extensions to the old flowcharting methodology that allows us to sort of represent events and objects and object-oriented programming and event-driven type work. Frankly, in my opinion, it's kind of a bolt-on. It doesn't work. I don't think it's very clean. I think it's cumbersome and sometimes awkward to understand and a little bit contrived. So fortunately, there is another way for our decomposition, our analysis to be done, and that is using the toe chart. And we'll learn about the toe chart shortly. Let's explore the toe chart, or task object event chart, that is more frequently used for the development of applications that involve GUIs, event-driven programming, and object-oriented programming paradigms. First, we develop the tasks. You'll notice this is very similar in many ways to the IPO model in that we determine the inputs that the user will provide: customer name, street address, city, state, zip, number of vanilla bean ordered, and number of strawberry ordered. We then do our processing or calculations, and then we display the outputs: the customer name, street address, city, state, zip code, number of vanilla bean pies ordered, number of strawberry pies ordered, and the total ordered, and the total price. We also note the other actions the user can initiate, such as printing the order, ending the application, or clearing the screen for the next order. With the tasks identified, we'll then map each task to an appropriate object type and give the object an appropriate name. So for example, customer name will be gathered and stored in a text box called text cust name. Finally, we'll note the event that the object must process in order to deal with the input or action that the object needs to execute in order to produce the desired result. Note that in many of these cases, we have noted none as the event. Now, don't get confused that that means that the object has no events or can have no events. It simply means we don't have to program any action for the events. So for example, the customer name as a text box has many events that can occur. Users can enter the text box with the mouse, they can leave the text box with the mouse, they can select the text box, and they can type in the text box. All of those are events, but none of those events have to trigger anything happening in our program. Instead, the user is allowed to type into the text box, and the event that causes things to happen will be the calculate button. The calculate button will make things happen when it is the appropriate time. The user will click on calculate, and that will cause the total ordered and total price values to be calculated and displayed. And so those are using inputs from the vanilla and strawberry order entry text boxes. But again, those text boxes don't have to wire up any events with code to make something happen, because it is clicking on the calculate button that is the event that we need to capture and that we need to provide code for. So as we go down the tasks are mapped to objects, and each object can have one or many events to which it responds. We simply note the events for which some code must be provided to make something happen. In this case, we will be providing code that occurs when the button calculate is clicked, also when the button print is clicked, the button exit, or the button clear is clicked. Based on the production of the tow chart, along with the interview notes and forms and other notes and analysis by the systems analyst or programmer analyst, the analyst will then begin to create a wireframe mockup or preliminary design for what the form or forms of the application will look like. Here's an example of a wireframe mockup. It is not functional, but can be used to check against the requirements to determine that all the functionality is present and that the design follows good design principles. The programmer will then translate the analyst's design from the wireframe mockup into an actual form in their coding. The programmer that designs this part of the application is often known as a UX programmer or user experience programmer. Okay, by now I'm sure you're wondering, what is my point in having walked you down memory lane and all this old school stuff with regard to the IPO charts and flow charts, and where am I heading with all this? And so here's the intersection of where your old procedural paradigm, which is still very much present and a part of what you can do in object-oriented programming and event-driven programming. And here's where they start to overlap. And the idea here is that the flow charting and the IPO stuff is sometimes a simpler way to think about things when you're learning before you have to get into all the complexities of the GUI and object-oriented paradigm and all that. So here I have count them, two Visual Studio projects open at the same time. And this is our old console-based code, and this is what was generated automagically for us by Flowgorithm. And so let me just give you kind of a hint at why the Flowgorithm tool and the old, DOS-based or text-based code is still useful. So here's our declarations, and those are for our variables. And if I just go ahead and copy those, I can come over and take a look in here at our code behind the form. And right here, where I've made a note to myself, put the declarations there. All those variable declarations live in both worlds. So I can paste that code right in here. And now I have the variables which I can move the inputs from the text property of my text boxes into the variables in order to do further processing on those. And let's go back to our old school project, our console based again. And if I come down here and our processing, our calculations were really pretty simple in this particular application. They're really quite simple. We're adding two numbers and then we're multiplying a number. But this could have been substantially more involved in terms of the logic and algorithm development that we had gone through. And again, once I've expressed it in code, if I copy that code over and come down in here where we need that logic and paste it in, there it is. So I've just sort of transplanted the muscle car engine from my old classic muscle car into this new high-tech and ever so sexier beast of the GUI. And if I've done my job correctly, that engine is going to run this thing like a beast. So there we are. And so now, all the declarations of variables are there. When I move variables and assign them from the properties of these text boxes in order to do other calculations or processing work with them, they're ready to go. And then the heart of the logic, where the calculations and processes are actually done, those really are still pretty procedural. They don't care too much about the object and event-driven paradigm that we're working in, and we'll start to see how objects are and their properties and methods give us some advantages over variables alone, how they work together. But this is really what's happening, and this is why this is still useful. So let's go ahead and show that this is now working. 1, 2, 3, happy place, Ventura, California, 93004, and we're having a party now, so let's have cream cheese pies for everyone. Let's order 10 and 10 and calculate it, 20 and a mere $500, but you guys are worth it. So there you have it, and clear it and exit. In summary, applications can be modeled by decomposing the requirements into inputs, processes, and outputs using an IPO model. Flowcharts are useful for visually representing the core logic of an application. Requirements of applications featuring graphical user interfaces, GUIs, or implemented using event-driven or object-oriented programming languages are more easily represented using a task object event chart or toe chart. The steps to create a toe chart are: identify application tasks, map tasks to objects, and finally, identify triggering events causing each object to perform its assigned tasks. This concludes the lesson.